Presentation on Amazon recommendation system and how data science helps on it, presented by Sai Priya and Tulasi Srirama, ECEI section, third year, SRM Institute of Science and Technology. Hello everyone. Have you ever wondered how Amazon seems to know exactly what you want to buy next? Whether it's suggesting the perfect phone accessory or recommending products you didn't even think of, there is a powerful system working behind the scenes. In this video, we'll explore how Amazon product recommendation system works and how data science is used to turn simple user actions into intelligent and personalized suggestions. Problem statement. In modern e commerce platforms, one of the biggest challenges users face is the sheer number of choices available. When a user searches for something as simple as mobile phone, they are presented with hundreds or even thousands of options. This leads to confusion and what we call decision fatigue, where making a choice becomes difficult. At the same time, manually searching for products takes a lot of time and efforts, and users may not always discover useful or related items. For example, someone buying a phone might forget to look for accessories like case or earphones. Another important issue is the lack of personalization. Without a smart system, every user sees similar results even though their performance preferences may be completely different. Because of these reasons, there is a clear need for intelligent recommendation system that can guide users effectively. Role of data science. This is where data science plays a very important role. Data science help us take a large amount of raw user data and convert it into meaningful insights. Every action a user performs on a platform, such as searching, clicking, or purchasing, is recorded as data. By analyzing this data, we can identify patterns in user behavior. For example, if a user repeatedly searches for gaming laptops and spends more time looking at high-end models, the system understands that this user prefers high performance devices. Such patterns, machine learning models can predict what a user is likely to be interested in. This allows the system to provide personalized recommendation instead of random suggestions, which greatly improves user satisfaction. An example scenario is presented. To better understand how this works, let's consider a simple example. Imagine a user comes to Amazon and searches for a smartphone. They browse through different options, compare features, and finally add one phone to their cart. At this point, the user might not be sure what else they need. This is where recommendation system comes in. Based on the past data from other users, the system knows that people who buys phones often also buys accessories like chargers, earphones, or phone cases. So it suggests these items to the user. This not only saves time but also makes the shopping experience smoother and more complete. At the same time, it increases the chances of additional purchases. Data science process overview. The recommendation systems follows a structured data science process. It begins with collecting data from various user interactions on the platform. This raw data is then processed and organized into structured format. After that, pre-processing is done to clean the data and make it suitable for analysis. Then exploratory data analysis is performed to understand patterns and trends. Once we have a clear understanding of the data, we build machine learning models to generate recommendation. These models are then validated to check their accuracy. Finally, the system is deployed so that it can provide real-time recommendation to users while they browse. Data collection and processing. In this stage, data is collected from multiple sources such as history, clicked products, purchase history, ratings, reviews, and even the time a user spends on a particular product. All of these give valuable insights to user behavior. However, this raw data is usually unstructured and messy, so it needs to be processed. During processing, the data is organized into structured formats like tables. Users are grouped based on their behavior and products are categorized properly. For example, all smartphones are grouped under one category and accessories under another. This step ensures that data is meaningful and ready for further analysis. The next step is data pre-processing. After processing, the next step is pre-processing, which focuses on cleaning and preparing the data. This includes removing duplicate entries and handling missing values, which are common in real-world dataset. Another important step is converting text data into numerical form, because machine learning models cannot directly understand text. For example, product descriptions are given into numerical vectors using techniques like TF-IDF. We also normalize the data so that all features are on a small similar scale. This prevents any one feature from dominating the model. Overall pre-processing ensure that data is consistent and suitable for building accurate models. The next comes exploratory data analysis. In exploratory data analysis, we study the dataset to identify patterns and trends. This helps us understand user behavior better. For example, we may observe that electronics is most frequently browsed category. We may also find that around 78% of users who purchases phones also buy accessories. Additionally, we might notice that most users are active during certain hours, such as between 7 p.m. and 10 p.m. These insights are very useful because they guide how we design a recommendation system. For instance, knowing that users often buy accessories with phones help us make suggestion better.
uh, uh, Hybrid recommended models to generate the accurate recommendation. We are using hybrid models combining two different approach. The first approach will be collaborating filtering, and which works under by finding the similar between user. For example, two users having same purchase pattern, the system will examine that, and it will show say similar product. The second approach, the content based filtering, which focuses on product features and recommend to the uh, person which what user has already shown interest. By combining two methods, we are overcome the individual limitations that makes a system more reliable and improve the recommended accuracy. Modeling techniques in system, there is three main techniques: collaborating filtering, recommended products based user, while content based filtering, recommended product based on future similarities. The hybrid model combining two approaches to a better performance. For example, the collaborating filtering might be suggest products because similar user liked it, while content based filtering ensure the product also matches the user interest. Finally, all recommended products are ranked based score before the showing to the user. Next, matrix filterization. As the part of collaborating filtering, we are using the technique called matrix filterization, factorization, specifically sign value of deposition of from singular value, decomposition, or SDV. In methods, we are representing user interaction from the matrix, where rows present users, columns represent the products. However, the matrix is useful too, because to do the interest in every product, SDV helpfully break the matrix into the smaller caption and hide the patterns, and also as this future helps to predict the how might rate and response to a product and they not seen before. Next, work of SDV. The SVD, the process began the construction matrix based pass interaction, and this matrix then the factorizing two lower dimension matrix. One represents the user and other represent the item. The model is trained using optimizing called which minimum prediction error. Finally, predicting are made calculated the dot product of user and item vector is given estimated rating, which use it to recommend the product. Key parameters and performance. The performance of the model depends on several parameters, such as number of factors and learning rates, regulations, and training. uh, these parameters are carefully turned to achieving the best result. Through the matrix help the ensuring that system is both accurate and efficiency. Validation and deployment. After building the model, we are validating compare the recommendation with actual user behavior. We check the user on clicking purchase and recommended products. It perform the not satisfaction. The model is improved using feedback. Advantages and applications. Advantages and applications. The recommended system may many advantages. It increase the by showing related products, reduce the search time and helps the discovering new time. It is improves the customer satisfaction and significantly boost the sales and revenue. uh, behind the e-com Behind the e-commerce, similar systems are platforms like Netflix, Spotify. Such content recommend the social media, suggesting post and job portals for matching candidates with opportunities. Conclusion. To conclude, the data science play a crucial role in enabling the personalized experience, recommended systems, and using data, understanding user behavior, and predicting the future. Performance helps the you find the related product quickly and efficiently, make the overall experience more comfortable and enjoyable. Thank you.